Okay, so we'll make a start and look at atomic structure and periodic table. Question 1. It's looking at the structure of a helium atom. So obviously from the periodic table, we'd have the numbers 4, 2, and then symbol of helium. Question number 1 is asking us to name the region where most of the mass of the atom is concentrated. Now, most of the mass of the atom is contained in the nucleus, which is in the middle of the atom. Most of an atom is actually empty space. So the electrons move in around the outside of the nucleus. So the nucleus is where most of the mass is contained. Relative charge of particle B. Now, particle B is around the outside here. These are the electrons. And the charge on an electron is negative charge, but it is arbitrarily given the symbol, the numerical value of 1. So the relative charge of particle B is -1. Now, corresponding to that are the protons, which are one of the particles contained in the nucleus. They have the equal but opposite charge of +1, so they compensate for the electrons within the atom, and the other particles which are also in the nucleus are neutrons. Okay, and they are neutral in nature. Within the helium atom, there are 2 protons, 2 neutrons, and also 2 electrons. So moving on to question 2. Potassium atom can be represented by the nuclear symbol of 39K19. Now the mass number is the top number. So for potassium, it's 39. For helium, in the previous question, that would have been 4. The atomic number is then the bottom number. So number 19 for helium, as I say above, it would have been 2. Now, in order to calculate the number of protons, that is equal to the atomic number. Okay, it's also defined as the proton number as well in some textbooks, but it's equal to the bottom number. Now, by definition, that's also equal in a neutral atom to the number of electrons as well, because as we've seen in question 1, the relative charge of an electron is -1, the relative charge of a proton is +1, and in a neutral atom, they balance each other out. Now, in order to calculate the number of neutrons, you have to take the mass number and subtract from that number the atomic number. So essentially top minus bottom if you've got a standard periodic table with the mass number on the top. So in the potassium case, it's 20. For heliums, it would have been 2.